Right. Hello, everyone. And I'm Artem, staff engineer in Productboard. I've joined quite recently, 2 months back. Before that, I had experience working in a corporate banking environment. And after that, spinning up R&D projects for medtech corporate, as well as refactoring of monolith in startup/scale-up environment. So, had some experience with architectures, and today I'd like to share with you some insights and I would say best practices that I came across too. And for a change, this one is not going to be about multi-platform. It's more like backend services, I would say, in general. And let's get started. So, first of all, we'll go through the definition of application architecture so we are on the same page and we'll understand what we're talking about. Do my best, like attempt to do so, and then we'll go through the common patterns. And in the end, I will show some practical examples on how I usually spin up projects in different environments, and of course, a lot of memes about pasta. You will see why in a moment. First one, as promised, right away, carbonara. Okay, let's get to it. Definition. So, if you Google what is an application architecture, top 3 links. First one, Wikipedia. Application architecture describes the behavior of applications used in a business focused on how they interact with each other and with users. It is focused on data consumed and produced by applications rather than their internal structure. Okay, Wikipedia never disappoints. Perfect description as always. But let's see some other definitions so we have the bigger picture. Next top link is a topic on TechTarget. Pretty much same thing with exception of the last part that I find really weird, to be honest. An application architectures ensures that applications are scalable and reliable. Okay, so good so far. And assist enterprises identify gaps and functionality. Like, this is weird. I have no idea how application architecture can help to assist gaps in functionality. In functionality, sorry. So, third times makes the charm. Red Hat. This one I find so far the best one. An application architecture describes the patterns and techniques used to design and build your application. The architecture gives you a roadmap and the best practices to follow when building an application so that you end up with a well-structured app. Really best one so far. And now, trigger warning, for the sake of this talk, I prepared my own definition. You're gonna love it. It's a directory structure of a project. Before you will start throwing potatoes at me or tomatoes, whichever you find, this is a crude simplification. Because first of all, it kind of omits event-based architectures like event sourcing and a lot of different things. But bear with me for a moment. When you start a project, you decided on your application architecture, first thing you would actually do is to set up your directory structure. And when you join a project for the first time, open the code base. Someone might tell you, we have these kind of architectures. You might find some diagrams that someone drew 3 years back and they left the company since. First thing you encounter is actually package structure. And that's how you can judge about the application architecture in a way. So let's open that and see how it actually works. And now past the theory of programming. So it's a joke in the internet that you could actually find correlation between software architecture and pasta, different kinds of pasta. Let's see how it works. First one, everyone definitely know, spaghetti architecture, also known as big ball of mud. Basically, it's an unstructured code base with dependencies between components that do not follow any kind of rules. By dependencies here, I mean in terms of one code base, not your external dependencies for the libraries. Although it has like this notorious reputation of being bad, it's actually good for something. It's good for fast prototyping when you're solo and you need to make some proof of concepts really fast and see how things work. So you don't need to think about the future of this code base, and yeah, why not? But if you will leave it at this and will not introduce any kind of structure, what will you end up with? Bad parts. Spaghetti in your data will make queries very weird and impossible to make them readable, and changes to the data model will be a hell of a thing to introduce. And spaghetti in your dependencies, same code base again, will do testing very inefficient, and circular dependencies you will encounter almost every day. So in general, spaghetti in your code base will lead to enormous time to market for new features over time and very, very sad developers. So let's break the spaghetti. As one Italian bass player, Davey, thinks, it is quite safe to do so. Ouch. It's gonna be better for us. I promise. No explosions. Okay, first one, lasagna architecture, also known as layered architecture or N-tier. Basically, your core base is structured into layers, and lower levels cannot access higher level ones. It's a very simple rule to follow, and this is actually one of the good parts of this architecture, is that you can explain these principles very fast and very easy. It's also promoted by Spring Boot out of the box, all of their examples and code snippets mostly in this and layered architecture, and at least it's some kind of structure. But it has its bad parts as well. So basically, this is how it looks like, and you can have different rules on how relaxed it is, like which layers can call which, but it basically goes from top to bottom. So bad parts. These layers are highly coupled, or tightly coupled. So change in one place over here or over there will require to change on all the layers, which with growing code base makes it very hard to maintain. And in general, this is well organized but poorly maintainable approach of how we can structure a project. Also, it often promotes unnecessary abstractions. And by that, I mean, imagine yourself, you have a service, you have a repository, you will have interfaces between them, some kind of abstraction, but then only one class will call only one class and that's it. So it makes this abstraction meaningless, but it's how you usually do it with this kind of architecture. Let's move to the next one. So vertical slices pizza architecture. It kind of breaks the theme of pasta, but close enough. Codebase is structured into flat packages based on business functionality. It might be hard to kind of grasp if you haven't heard about it, but on the next slide there will be a diagram and you will see what I mean by that. And components are isolated based on the domain. Good part is that it has very flat package structure, so you kind of see everything related to one feature right away. But it makes separation and it also makes separation to independent services easier. So when you have bunch of business features and you want to spin up different service, like kind of separate it to another service, just grab these packages, drop them, should be good to go. Now, how does it look like? Okay, so basically it's like this layered architecture that we've seen, but instead of organizing your code base in actual layers, we will organize them into vertical slices. So imagine a package with one feature like create order will have everything you need for UI, application, domain, and database. This leads to one of two things. You will either have a lot of duplicated code, or you will share responsibilities between these slices. First one is kind of bad, but it's the way how you should use this architecture. Second one is probably how everyone does it because it's impossible to have that many duplicated code pieces. So over time, these slices tend to be tied together, which makes it lose its point. And in bigger code bases, it might be hard to navigate. Imagine yourself, you join a project, it was running for 2 to 5 years. You open the code base, and first thing you see every feature that this code base can do. Like it might be overwhelming. And over time, flat packages, although it's a good part, they can actually become messy. Because if you think about it, you will have like for more common domain objects like controller, service, something to store the database, but then something to send to Kafka, Elastic, and whatnot, and you'll have a lot of objects to support it. So let's move to the next one, ravioli architecture, also known as hexagonal architecture or ports and adapters. This one, it's really hard to summarize it in a couple of sentences, and on the next slide we'll have a diagram. It's going to be much more easier to understand. But the main idea is to isolate business logic and create separate packages for input and output of data that will depend on core of business logic. And the components are isolated based on their capabilities. So good parts, it's highly structured and flexible, and it scales very well with growing amount of business features. And I would say it's the most scalable, but at the same time, it's very heavy to actually develop it and maintain in terms of amount of code you will have to write. So let's see this diagram. Basically, you have your business logic. And if you follow this by the book, in the core of your business logic, you will have plain old Java objects or Kotlin objects or whichever language do you use. It will have no frameworks, nothing. Pure business logic. It depends on nothing. Then you will have input ports. And by input ports, here we mean like your REST API, GraphQL API, Kafka that you consume, and it will depend on its business logic. And on output ports, is our connection to database, producing of Kafka messages, and third-party connections over HTTP protocol, for example. So if followed by the book, it's very heavy because imagine yourself you have like core entity as an order here, and you need to consume order, so you have representation of this entity here. But these adapters, they're independent of the cells, so we'll have Kafka representation to consume of order, and then to store it, you will have representation for database and to send it elsewhere. Basically, a lot of mappers and a lot of representations of the same entity. But in bigger applications, like in core banking, it's actually necessary in a way because in case you will introduce some other port or store something in different kind of database or start sending something to Kafka for some reason, if you need it, you will not break your business logic by that because it doesn't depend on anything. Everything depends on it. Well, another bad part, I don't know how if it's really a bad part, it's simply unnecessary for smaller code bases and absolutely not suitable for proof of concept type of projects. Okay, let's move to a practical example. So basically, now I would like to show you how I usually start projects. Kind of a combination of everything we saw here now. And after these practical examples, folks who write and use Spring might look forward to another special tip. Okay, imagine yourself, you're starting a project, empty folders, nothing. Usually create adapter and domain, which already looks like ports adapters, but it's not going to be ports adapters, I promise. So in our domain, we will have a model. And let's say it's item and order, doesn't matter, just a couple of objects. So we need to read them, and we will define a repository. Like important thing that it's interface, because still it's inspired by port adapters. Domain cannot be dependent on anything, so it defines interface its needs, and actual implementation of repository will be in adapter. Then we can have facades, services for business logic, and again, here it's a lot of flexibility on how you can actually create this. You might omit facades, or you can expand them in the future by creating packages based on business functionalities, like in vertical slices, for example. And now let's look at adapters. First two most common API that you will expose, and persistence. So in API, we can create simple REST controller, request response, and in persistence, entities for item and order, and JPA repository. So pretty much the same amount of code you would write in any kind of architecture if you want to have two entities, but organized in a way that you can expand it in the future into something more mature. Because here I have like 3 models already, but it's unnecessary. You can reduce it if you feel it like you need it, and introduce them later. Most important is the structure. Like later you could also add mappers, validation, because on different layers, like in API and in domain, you'll have different validation rules because you validate different things. So a couple of tips that didn't made it into the presentation, and they actually deserve presentation on their own, and just things to consider. Package names based on their domain rather than technology. It's a hard rule to follow, because often you want to name something just Kafka, Elastic, and forget about it. But consider at least trying to name them by their domain responsibility and what they are doing instead of what they are. Sometimes there are definitely exceptions, and you just name something Kafka if it's configuration for Kafka. Second one is use type system to the fullest. This is an interesting one and is better explained with an example. Let's say you have order entity coming to your code base and you need to validate it. So you usually throw it into validator, and if everything is good, we're moving forward. If something is bad, we throw in exceptions, returning errors, and explaining what's wrong. But what could you actually do if you would like to utilize this type system to the fullest? Is to return from validator another object, another type, and name it something like valid order. So later down the road, your services will consume not order, but valid order. And this way you communicate through a type system that services should only work with valid orders. So it's an interesting idea to utilize this type system this way. And last one, refactor when does it feel right. You might start a project in one approach, but over time, projects evolve, you have more features, and it might be good to consider if you need to refactor. Okay, and now promised another special bonus example for Spring guys, girls. Reconsider AutoWire. If we'll look to the left, we have order service, item service, and a facade that has dependency on item and order service. There is no AutoWire, but we can see these green beans that identify to us that it's managed by Spring. So how can we achieve that? On the right, we have configuration, and we define beans manually and inject them manually. Why would you do this? So one of the reasons is that if your code base is growing and you use AutoWire all over the place, then you have no control over what can be injected where. And it might get lost in a bigger code base and create dependencies that break the rules of architecture that you've set up. And basically, when it's in one file, it's much easier to control it and to communicate it to your, for example, new colleagues that are joining. You can see that Okay, we have to wire like service to service facade repository and blah blah blah. So it helps to keep the code base clean. Okay, and that's it, folks. Cool. And let's see what we have in Slido. Uh, what you use to connect your ravioli pieces? Spaghetti. Tomato sauce. And I'm actually wondering if it's a real question or just a joke. If it's a joke, then it's a good one. Okay, what if we'll go back? So if this is a ravioli, you would connect it with output port and input port. So it strongly depends on what are your needs. You can connect them with whatever you want. Thank you.